So, hi everyone, once again, thanks for inviting me to talk about DevOps Guru for AWS Serverless applications. So, in order to understand the talk, you should have some kind of basics in AWS and especially in serverless services. Everything else I will explain you as well. Probably if you come from other cloud providers like Azure, you will have some similarities, but I don't really know if some similar service exists in that area. So yeah, my name is Vadym and I'm Ukrainian native. Probably you see this on my t-shirt. I have two passions. That's mainly AWS Serverless and Java. And yeah, we'll see kind of mixture of this also on this talk. I'm one of the co-organizers of Java user group Bonn. I currently live in Germany for many years, and I'm also AWS Community Builder in the serverless category. So just can combine my passions. You can contact me via LinkedIn, Twitter, Mastodon, or drop me a private email if you just have questions and so on. I will do my talk and then I will look into Q&A and also answer your questions. So let's start. Yeah, several words about the company. I'm working at ip.labs in Bonn. We are 100% subsidiary of Fujifilm Europe, also based in Düsseldorf. We provide software for designing products, photo products and purchasing photo products like calendars, photo books, prints, posters. And we started in the data center, but in the last 5 years, we completely migrated to AWS and use some kind of combination of standard infrastructure, but also Dockerized environments and serverless. So lots of experience just talking about this stuff. So now we can start with the AWS DevOps Guru. And first of all, what is about? So the service is mainly about, this machine learning service, but you don't need to be expert in machine learning. Neither am I an expert there. And it aims at improving application performance and availability. And what it does, it detects behaviors that deviate from normal operating patterns. So you can identify your issues long before they impact your customers and so on. And to these issues belong increased latency and error rates like timeout, throttles, and so on, but also resource constraints. So each AWS account has its limits, each AWS service has its limits, and just if you're about to reach that limits, you should just be notified in advance. We will focus mainly on serverless stuff here, but that's kind of overview what the service does. Once again, it automatically detects operational issues. It helps you to quickly resolve them. It doesn't resolve them for you. Yeah, it easily scales and maintains in the sense of, especially in the serverless world, which is event-driven microservices world. You have a lot of lambdas and for your business logic, API gateways, and so on, and just you have a lot of CloudWatch metrics and alarms just to take care of, to maintain, and the service can just, we will see it very easy to enable simply one click, more or less. And also reduce noise and alarm fatigue, because it just also detects if this is one particular, some small error with no impact, and then the service recovers itself, so nobody should be notified at night and so on. You probably know if you just taking care of a lot of alarms, you have false positive, then you shut down, close the alarm, and then when you needed it, then it just was turned off. Yeah, that's kind of normal problem in the IT. So the question is, how does the service work? The service combines a lot of existing AWS services. First of all, you will have to select the coverage from AWS Cloud Formation, what the service should observe. We will also see everything, some particular applications, some tagged resources, and then it pulls the data sources like CloudWatch for metrics, config for just configuration of account, environment, CloudTrail for each API call, for example, deployment, infrastructure change, and also X-ray for observability. And just it analyzes the stuff, but also just builds the baseline, what's the normal stuff, how the application should run. And if it deviates from it, then the DevOps Guru will create kind of insight. We will look into this. And there are also third-party integrations into some professional incident management tools like PagerDuty. I will show you we're actively using it, but also AWS own Ops Center. You can also do the stuff via simple notification service and so on. So if you are interested in how it works from the machine learning perspective with this automating reasoning, you can look into the article below. I will, of course, share my presentation. You will see a lot of AWS services like VPC Access Analyzer, IAM Access Analyzer. They're also based on this machine learning automated reasoning algorithms to provide you value. Yeah, and that's no exception. I think we will see more and more services based on this. So we will look into kind of base serverless application. I have something similar, or we at ip.labs built something similar for us because we are doing a lot of stuff with the photo products. We need to create them, update them, delete them, and the same stuff is here. API gateway for the public-facing HTTP endpoint, and then you see 4 Lambda functions like get all products, get product by ID, create product, but also delete product, and everything is stored in NoSQL database DynamoDB. Yeah, I have one just particular situation that I will show you what insights can be generated in case the create product Lambda is triggered. Then I additionally send the message into this SQS. The reason for this is I just, sometimes you need another department who just in case the product is created, just is taking care of pricing and contracting, and they needs to be notified. The SQS queue is notifying, and then we have another Lambda for the business logic that actively polls this queue and receives this message and does something with that. So this is kind of very basic application. Of course, real world scenarios will probably contain much more Lambda functions, at least probably also other services. But in order to have understanding what happens, we will just set this as basic. So first of all, how to set up DevOps Guru. Simply you go to the DevOps Guru service, and just then you need to select what resources you analyze. So no value in selecting none, then nothing will happen. You can select everything. Yeah, just all resources will be analyzed, or what I did, CloudFormation stack. And CloudFormation stack is a kind of application which is deployed as a CloudFormation stack. In case of this is DevOps Guru demo. That's kind of application, the architecture I showed you, but you can also say I'm not interested in some particular application or only a subset of resources of one application which are tagged on this key value pairs. Then you can also select this. This is mainly the thing. And then, yeah, DevOps Guru is running. You have the option, if you use AWS organization, if you have kind of sub accounts, you have organization, main account and team have sub accounts. You can select this also for on the organizational level as well. So this is how the dashboard is looking. Yeah, in case you have here reactive insights, proactive insight, we will look into this. This is the number of resources analyzed, number of Lambdas, API gateway, DynamoDB in total, yeah, a number of impact applications. So you see probably this is the screenshot and the alarm or incident has been created. So and now it's how the incident looks like. You see here the incident name, you have status, severity, creation time, and so on. So I experimented a lot just to show you what incident can be created. So generally how I proceed. So in the real world scenarios, of course, you will have all that stuff, but in order to show you that, I, of course, try to imitate some incidents. And of course, just I'm doing this in private, and in order to save money, I needed to proceed some particular way. And the first one is, for example, in order for DevOps Guru to work properly, you need to warm up applications. So the documentation says it takes up to 1 day to create the baseline, how the application is normally working. But my example showed that even 1 hour was enough of simply running the application. Then you may also, yeah, so the incident may be detected after 1 hour. So what I did just to produce all these errors, I reduced the quotes. So each AWS service has its quote. I set very slow quarters. I will show you just in order then to exceed this quarter and not spending too much money. And in the case of latency, I simply add some latency. So the usual response time was 1 second, and then I added sleep time 20 seconds just to see, yeah, if such incidents may be detected. Then you can use the stress tool, whatever you want. I used Hey tool. It's very easy to install. You see the link below. It works similar to the curl. You can use locust, you can use JMeta, it just doesn't matter. Yeah, and in the end, I wanted to see if this DevOps Guru recognized these operational issues, and then I remediated the stuff by removing these latencies or just stopping the incidents, just stopping hammering or increase the quotas of the services just to stop the incident of that way, or just restore the application. And I wanted, of course, to see whether the DevOps Guru will close the incident, recognizing that just the application is working fine. So yeah, let's start with the DynamoDB. NoSQL database, you don't need to be the expert there, but you have two modes how to work there, how it scales. You can have the dynamic scaling, so it will scale probably just dynamically, but it may cost you more, or you can define kind of read capacity units and write capacity units. So how many reads per second, more or less. It's much more complicated. And what I did just to reproduce the incident, I set this read capacity value of DynamoDB table to 1. So simply speaking, 1 read request per second is allowed. There is also other stuff that plays here, but generally you will receive error if you burn your credits and then have more than 1 request. So what you see this with the Hey tool, I just hammered my request. This is my URL of the API gateway. So this is how this public service can be accessed. I also secured it with API key, so just nobody can simply request this URL. It's kind of security stuff. And then you see Hey, and then you see the relevant parameters. So -z is the time for running the stress test, 15 minutes. This is how many requests per second is allowed, 20, and -c, how many requests in parallel. So how many containers, kind of also 20. So if you see, there will be 400 requests per second for the time period of 15 minutes. What I'm currently doing, and just to burn the burst credits of DynamoDB, and then to reproduce that only 1 read and I'm just doing 400 will be allowed. And now we will see what's been recognized here. So DevOps Guru recognized after 5 or 6 minutes the incident and gives you the proper name, DynamoDB throttle request anomalous. So this is the anomaly with the DynamoDB. You see the high severity, so throttling is always high severity. You see start time, end time, and all that stuff. Now we will go into other stuff that DevOps Guru will show you. It just gives you also the time period when it starts, all the metrics that are relevant. You see here read throttle event, you see DynamoDB in the table name. So you see, okay, this table was throttled with the reads. And as a consequence, Lambda, which is calling DynamoDB, will also have errors. That's normal stuff. The database is not responding, and then business logic can be processed. So sometimes you have more errors. What is also important, you can also see exactly count, not only the time period, but exactly when it started, how heavy it was, how many errors did you receive, how many requests have been throttled, all that stuff you will receive for all your metrics. Then you can jump into the logs, especially of Lambda. So for the sample of that time period that it occurs, so you can see everything that was logged. And in below, you see kind of relevant events. And here you can see when the incident started, but also what has happened. Probably, are there any deployments? Are there any infrastructure changes? And in that case, of course, it has been one. You will go into the CloudTrail, which logs each API change, and you see DynamoDB table name, products table. There was update triggered nearly before the incident started. You can click on this link and dive deeper, and you will see exactly the event that happened. Yeah, you can see, okay, read capacity units is now 1. Yeah, okay. But you also can click here on the timeline just to see the diff. And now you see, okay, what has happened? Somebody changed read capacity unit from 5 to 1. Yeah, so that may help you to resolve the incident if you just go and see if it's deployment relevant, that maybe some other changes have been done, like timeout for Lambda and so on. So you can, if it's something really infrastructure related, it may help you a lot to identify the problem. You will also receive recommendations, so some links where you can follow just to read what all these metrics mean. Generally didn't help me or somebody who doesn't know deeply what these metrics mean. You have stress kind of incident and then start reading those links is generally not very productive. So probably you have the knowledge and you just need to go into the monitoring stuff and also into other stuff. So what other stuff is possible with DynamoDB? You can also see if you reach account limits for the table. So each service has its limits. You see table level limits, account level limits. So in case you reach with a number of requests, one of those limits, there will be also incidents. And also you have the possibility when you define read and write capacity units also to define scaling. So in case you have utilization of 70% for reads, then you can also increase the number of capacity units, but it may also happen that you increase to the maximum and still reach that limit. Also in that case, the alarm will be received. So that's probably everything for DynamoDB. Let's look also into the incidents of the API gateway, what's possible. And the most easy to, I would say, the incident to run with if you have too many requests or the quote exceeded. So for the API gateway, there is a possibility to define the quota per day, per month, how many requests are possible. And it's a best practice to define something. And you can also define 1,000 requests per second is possible and 500 bursts. It just doesn't make any sense because the overall quota is low. But I set it that low just to easily run into that incident. In the practice, you may. So the limit is 10,000 requests per second, and you probably would like just to quote so that one API gateway doesn't consume the whole capacity of your account. And this is the one stuff. Where if you exceed this quote, then HTTP 429 error will be thrown. Yeah, there's too many errors. Another stuff which is possible that you run, for example, into HTTP 404 on the API gateway with a not found error. It happens when you, for example, query for the product. We have the kind of product API for the product ID which doesn't exist. For example, I don't have any 200 product IDs, and if somebody is just doing something like this for 15 minutes, one request per second with this not existing product ID, then DevOps Guru will recognize that it's not one request that delivered the error, but it's just 15 minutes in a row with errors, and they will give you this picture. So the incident API gateway 4xx error, they don't differentiate between HTTP error codes 229 and 404. That's one of the drawbacks. So you will see this generic message error average on 400, and you see the API gateway, you see the time period, and so on. And in this case, the severity medium, because 400 errors are not 500 errors. So they just mark this as maybe medium, maybe somebody is doing DDoS attack against a not existing product, and it's not the problem itself. So yeah. All other metrics will be similar. You will see the number of throttled requests in the time period and all that stuff. Also troubleshooting guide, which is not very helpful, and so on. So now let's move to what may happen with Lambdas. Is just much more. You have business logic. There are much more that can happen. So you have the concurrency limit of all Lambdas in parallel per account, which depends on the region between 500 and 3,000. And sometimes you just want to resolve some low concurrency for the function. For the ease of experiment, I said only one, this function is get product by ID, has only resolved concurrency 1. So only one function can be called in parallel. And now I am doing the stress test for 15 minutes, calling 25 times Lambda function per second. Yeah, where only one is allowed, and then the queue will be built of not executing functions. And from some particular time, then the throttling may occur because the system cannot just, execute all this business logic. And in that case, Lambda throttles anomalous has occurred. You see throttle sum on the Lambda, the name of the Lambda. And of course, if Lambda is throttled, then the response sent back via the API gateway will be then 500. And that's in this situation, you see two errors coming together, and you see that throttling is always high priority, and so on. You see the metrics for throttling, you see the metrics which will correlate for the API gateway 500 error. So just that's working. I had also heavy tests where I exceeded 1,000 account limit in the time. So there you will see more metrics. For example, number of Lambda invocations will be shown because just it exploded. I tested 5,000 invocations in parallel. And they say, okay, just you usually have 10 functions, Lambda functions executing in parallel. Now you have more, and then they will show you more metrics that will give you a hint that something is not working properly. There are also other errors, just if Lambda cannot be initialized because of the less memory. Just, for example, Java application requires 256 megabytes for Lambda to run. If you give less, then you also run into errors. Everything was recognized. For the sake of time, I will jump to other incident, for example, increased latency. So generally, this request from the API gateway, asking Lambda, asking DynamoDB takes, in my examples, written with Java, something below 1 second. And I want just to figure out what happens if I add a latency of 28 seconds. Yeah, so I don't run into the timeout. Timeout of 30 seconds, I add sleep time of 28 seconds just to see now I have 28 seconds more latency. Will it be recognized? There is no error. Everything can be proceeded and the response is going back, but just with 28 seconds more. In this case, yeah, you will receive the medium severity because it's not the error, but you will see the insights Lambda duration anomalies. Yeah, so this latency duration. You will see that this Lambda get product by ID has deviation with duration P50. Sometimes they show P90. So there is a deviation of the mean time of running the stuff. So that's the latency stuff. And you also see this, the time frame where I ran the experiment. So also latency will be recognized. I wasn't able to figure out by how much the average latency should be increased. For example, I added 5-second latency and then there was no insight generated. Probably that's okay because from 1 second to 5 seconds, it's probably not very, very huge additional latency to consider. So I would like to run the next experiments to figure out what by how much should I increase the latency so that the insight will be created. But in that case, it was right. So there will be another more complex experiment that I would like to show you. So in that case, you see, when creating product, I send this message to the SQS queue, and there is the Lambda which polls this message. So what will happen if this Lambda, which is asynchronously polling, will receive the timeout? For example, timeout that I add sleep time, which is more than 30 seconds that Lambda should run, so the Lambda will end in the error. In that case, the message will not be fetched from the queue. So then the message will remain in the queue, and the asynchronous poller works like this, that it will be retried with exponential backoff. So there will be a lot of retries even within the first 20 minutes with the same result. Lambda is going to timeout, and then the message will result in SQS, will remain in the queue. Yeah, that's what I would like to show you. That, yeah, that was the Lambda function with 25-second timeout and then added 26 seconds of sleep time. So the Lambda will not be finished successfully. And yeah, I have here also sleep time, so the divisibility timeout. And yes, what will happen, you will always see this message in flight 1. So I send one message, created product, then Lambda runs into the timeout, and the message remains in the queue and can be processed. And if then the retry will automatically proceed it. And after, I will say 6 minutes, you will see this picture. So the first error will be error sum. On this Lambda function create product, it will be thrown in case you have timeout, but also in case of initialization error because of less memory. And this message, approximate number of message not visible, also indicates that the queue, SQS queues, contains the messages that cannot be proceeded or visible from the Lambda function. So you will have here 2 different alarms from 2 different services. The severity is high because of timeout, and this error on Lambda, and so on. So that was one of the most complex incidents that I reproduced, and yeah, that was right that generally these two alarms have been also recognized. So there is a lot more to show you, but I think I will wrap up with this stuff. With the reactive, so through all the stack you see API Gateway, DynamoDB, and Lambda inside have been recognized. There is also another kind of errors that DevOps inside Guru recognizes. These are proactive errors. So what do they do? For example, you create DynamoDB table, but you forget to enable point-in-time recovery. It's simply checkbox, but it gives you backup and restore functionality. So you will receive that stuff regularly, that there is just kind of error there. Also, if you, for example, DynamoDB, I have provisioned 5 write capacity units, but I don't create too many products so that the writes to the DynamoDB don't require 5. And they say you are over provision the table, so it's underutilized, you can save money. So all this stuff in the proactive insights, they give you hints that in case you, for example, in that scenario with SQS queue and asynchronous Lambda, in case of errors, you have the best practices to enable that later queue, so that the messages that cannot be consumed will be also moved to that later queue, and then you will be notified. I didn't do this, and also proactive alarm was shown to me in that situation. So I would say, yeah, I was pretty satisfied that proactive alarm stuff, they also improved this. I received more and more proactive alarms for the same configuration, pointing to the errors that I have. So I see that the service will be developed steadily. So some words about the integration. So you can integrate this into the Ops Center of AWS. You can integrate it to the PagerDuty. I will show you this professional incident management tool, and you have also Atlassian Ops Genie, the same as PagerDuty mainly. So in case you use PagerDuty, and this tool allows you just to set up on-call duty. Yeah, this professional incident management tool, you can set up teams which do on-call duty and then route the calls in case the incident comes to some particular people, then you can rotate. So lots of complex stuff that can be done there. And what you would like to do just to receive the alarms, incidents from DevOps Guru, so the PagerDuty can do its work. And there is in the area of integration, DevOps Guru integration. So that's enabled. So there is a collaboration between AWS DevOps Guru and PagerDuty team. And in case you enable this integration, the one integration URL here will be generated for you. What you should do then, just copy this URL and then go to the simple notification service of Amazon and create one topic, and then say its protocol is HTTPS in that case, and provide this endpoint generated by PagerDuty for you. In this case, yeah, then you can confirm you have then this SNS topic, and the next step is simply to go into the DevOps Guru settings and simply enable this SNS notification. Yeah, so we created this SNS topic, and then now you can say, okay, I would like to use this SNS topic for DevOps Guru notifications. Yeah, and then notification will go to the PagerDuty. This is how it looks like in the PagerDuty, mainly the same as in the DevOps Guru Insights. But personally, when I receive the incident, I acknowledge them in the PagerDuty. Yeah, it's the tool, the official tool. Everybody is looking there. Statistic will be generated, and so on. So for me, it's in the end the source of truth. It's PagerDuty as an incident management tool. So now, what services are supported? I showed you mainly AWS serverless services, but you see you have here EC2 instances, load balancers, container service, Kubernetes service. So also standard services are there, but also other, I would say, serverless services like CloudFront, like Kinesis. So lots of stuff that they really monitor, even step functions. So depending on the scenario, you may receive alarms. And pricing, a bit complicated. So you have two groups of resources. Lambda and S3 bucket will be priced with this amount. per hour per resource, so per each Lambda function or per each S3 bucket that you would like to monitor, you pay this price. And for all other resources here in the price group B, you pay, I would say, 50% more per hour, which may be totally okay. And if you use single table DynamoDB design, then you have only one DynamoDB table, you will be priced this price. And if you multiply this and you would like to calculate some monthly charge, it's only several dollars for one DynamoDB table. The same may be true for API gateway. It's not expensive, but it may become expensive if you have hundreds of Lambda functions. If you will see the price example, I think even the next slide. What does it cost for this application? And you see here we have 5 Lambdas, 1 API gateway, 1 DynamoDB table, and 1 SQS queue. The total price per month is $19. Yeah, but if you just think you have not 5 Lambdas, but 500, for example, then this will cost you, $1,000, I think. Yeah, so multiply by 100. So only Lambdas will cost you then $100 per month. It may be okay, because if you have so many Lambdas, then you have to take care of all these metrics and alarms. It may also cost you time, just which you will probably better use for writing business logic. But depending on how you design the application, so the Lambda functions, the number of Lambda functions is one of the factors here. So now to wrap up, what the situation, the conclusions, observations, suggestions. So all errors have been correctly recognized so far. It took 6.5 minutes to create an incident after anomaly appeared for the first time, which is okay, because they would like to avoid false positives. So they observe if the error disappears or not. But also correctly, no insights have been created from temporary incidents. For example, I created temporary throttling. So 10 Lambda requests have been throttled, and then I increased the limit, and so elastic scaling happened, and then there was no throttling. That's the correct. So only for several errors to wake somebody up, probably not okay. So I think that's fine. They can draw the line. The recommendation could be more precise in several cases. Yeah. So for example, I saw that Lambda has been throttled because of reaching individual function concurrency limit for some particular function, or the total AWS account limit. I just throttled with both scenarios. The error message was the same. And it's a good hint just to say what exactly the metric I throttled. There also was no differentiation between Lambda timeout or Lambda initiating error. Yeah, and that's a huge difference. In both cases, I received Lambda error. But I have to dig deep into logs, and then I see what happens. But I would like to save time. This is what we have been talking. API gateway only shows the generic 400 error. And it takes time, because it's just medium incident 400. And for me, it's a difference between 429. It's more infrastructural throttling, and 404. This is the application, which throws not found error. And the problem is there also that I don't always see which Lambda function caused that error. So I see only error, but not exactly what Lambda function. And that may help, because, for example, only one function with this get product by ID throw 404, but I probably have a lot of function which may potentially throw something, and I have to dig deeper to understand that. That will help just to see, okay, what function or functions cause all those errors. This duration anomalous, latency, it took a huge time, sometimes more than 13 minutes, maybe also just for the incident to be recognized, maybe because of the medium severity, and also have some things with this proactive insights. Now they improved. They are now shown very quickly. Several months ago, they just generated this one time per day. And if I improve something, it took 2 days to recognize that I fixed something, like a point in time recovery. Now it's instantly, but sometimes I see some particular incident, proactive incident missing, which may help me, but probably it's out of the stuff. So log groups, where you just can dive into the logs of Lambda for some particular time frame. Sometimes they didn't appear for me. Yeah, sometimes I see them, it helps me, but sometimes I don't appear for me. But the most important point that I'm missing is the integration with the observability tool like X-Ray or CloudWatch Service Lens, which also use X-Ray. So it's not enough for me to see logs. I would like to see metrics, so traces, and this observability part, because sometimes the incident is so much complex. I don't know what is the root cause and what is the consequence. And if I need some kind of link to go into the X-ray and see what's happened and, exactly in that time, and just not a way around going to X-ray and then selecting some timeframes. So this integration is missing, but generally I would say that the product is improving. So now I'm finished with the presentation. What I would like to say why I believe in that tool, because AWS has lots of experiences running these workloads in production, especially for the services they developed and managed by themselves. All that stuff, Lambda, API Gateway, Kinesis, Step Function, these are all kind of cloud native serverless services from AWS. And with that experience running in all that regions and all that availability zones, they have really good understanding of what's normal behavior and what's not normal behavior. So they really can generate very well prepared insights and help you to improve your, I would say, availability of your application. So now, thank you very much for listening. I know that for the people not familiar with AWS and serverless, that maybe not the right talk. So I saw people left. That's totally fine. And now I would like just to stop sharing the screen. Thank you very much for the invitation. And yeah, let's stay in touch.